Hi everyone, it's Mrs. Summer here to talk about lesson 303, line of best fit. The objectives for today's lesson are that students will be able to interpret data from a graph, identify whether a graph has a positive correlation, negative correlation, or no correlation, and draw the line of best fit for a graph. The line of best fit, or a trend line, is a straight line that best represents the data on a scatter plot. This line may be passed through some of the points, none of the points, or all of the points. So how do we find the line of best fit? Well, step 1 would be to graph your data. Step 2 is to draw a line, the line of best fit through your data. And then step 3 would be using 2 points on your graph that are closest to your line of best fit. Write the equation of the line. So here are some tips on drawing the scatter plots and best fit lines. So ignore these 3 and A, but the table gives you the average class score, Y, on each chapter test for the first 6 chapters of the textbook. And as you can see, this person graphed, so point 1 was 1 and 84. So X was 1 and Y was 84. So they marked those points on the graph for everything in the data. Then they drew their line to make that's closest to hitting most of the data. Okay. And then they picked approximate the best fitting line for the data by hand. And by doing that, so they picked this point 6 and 90 because that was on the graph on your trend line, and 386. So because they were the points that were closest to the trend line that they drew. And then approximate the best fitting line. So now you have 2 points. So you have points 386 and you have point 690. So using the equations that we learned in Unit 2, they found the slope, which was 90 minus 86 divided by 6 minus 3, because they used this as x1, x2, y1, y2, and used the slope formula. Then y equals mx plus b. They needed to find their b. So they took a point on the line, 86, 3. So 86 was your y. They found the slope to be 4/3 times x, which was 3, plus b. And then they solved the equation for b. So 86 is equal to 4 plus b. So b is equal to 82. So they were able to find the equation of the line was, let me erase these things. The equation of the line is y is equal to 4/3 x plus 82. Try. So here's a set of data. Oops. You should draw a scatter plot with this data and then draw a line that goes through like most of the data, and then write your equation using 2 points that are closest to that line of best fit. So on this last question, I graphed my stuff using Google Sheets, and then I added my trend line, so it would be nice. But you can do this by hand, and it'll work just as well. So now we need to find 2 points on the line, and I'm going to use that point, and I'm going to use, let's say, this point. So those coordinate points are 9, 19, and 4, 9. So I'm going to find my slope, and I'm going to do 9 minus 19 all over 4 minus 9, which is equal to negative 10 minus negative 5. So my slope is equal to 2. So now I'm going to pick a point because I have my y equals mx plus b. And I'm going to pick these 2 points. And I'm going to plug this 4 in for x, this 9 in for y, and this 2 goes in for my m. So I'm left with 9 is equal to 2 times 4 plus b. 9 is equal to 8 plus b. Subtract 8, and I get 1 is equal to b. So my equation of this line of best fit would be y is equal to 2x plus 1. So this line is that equation. So what is a correlation? A correlation is the relationship between two variables is called a correlation. The data can have a positive correlation, negative correlation, or no correlation. The number that's below, so these numbers, that describes how strong the relationship between the variables is called the correlation coefficient. Its value is between -1 and 1. The closer it is to -1 or +1, it's the stronger relationship. So if we look here, positive correlation, a positive perfect correlation, if we were to draw our trend line, it would fit all of the data. Now, if this high positive correlation, if we draw a trend line, some of it will fit, and it's still very close to that line. The data is still close to that line. Here, low, it's not as close. The data is not as close to that trend line. No correlation, if we look over here, no correlation. It means the data, there's nothing, you can't make any type of reasonable. It's not anywhere close to the line, and it just looks all scattered throughout. A negative correlation, if we look, low correlation, it's that it's going the opposite. It has a negative slope. High negative correlation is that it still has a negative slope and that the points are a little bit closer to that line. And a perfect negative correlation is that if I could draw a straight line, that data would go through every single point. Now, I cannot stress this enough. Correlation does not imply causation. And this is where news media comes into play. They will say, oh, because if we're looking at this high positive correlation, that, oh, this thing must have, this X must have caused Y to happen. All a correlation says is there's a connection between the two, but it does not tell us whether X caused Y to happen. So correlation does not imply causation. Here, what type of correlation is this? Does this graph have a positive correlation, negative correlation, or no correlation? Well, if I look at my data, my trend line would fit like this. And most of the data is near close to that trend line. So yes, negative correlation. Try. Does this graph have a positive correlation, negative correlation, or no correlation? This graph has no correlation. The data is not close together in any type of positive or negative trend. So interpreting graphs. At what temperature did this ice cream store sell the least amount of ice cream? Well, I am going to look here. This is the number of sales as my y-axis. And so my least amount of sales is right here. And at what temperature? Well, I can safely say that it is 91, 92, probably 94 degrees. So 94 degrees is when the store sold the least amount of ice cream. You try. This scatter plot shows student scores for quiz 1 and quiz 2. Did any students earn the same score on both quiz 1 and quiz 2? And explain your answer. So here's that data. So did any student score the exact same score on quiz 1 and quiz 2? So yes, one student did score a 15 on quiz 1 and a 15 on quiz 2. So if we look at this score here, and we can tell that if I go up to 15, which is about here, and then I go across, and it's 15 as well. So that's what it's asking. So quiz 1 score, we look, and is it the same as quiz 2? Yes, it is.